Hello, geometry students. Today we're going to be going over the Unit 1 activity. This is actually the second activity in the Unit 1 book. It has to do with reflections and so forth, and lines of symmetry. If you have your textbook, this textbook, and you turn to page 568, and we're going to be doing activity 1. So if you look there, it talks about what symmetry is. And so what symmetry means is it's like the same on both sides, or it's a mirror image of itself. And oftentimes we consider, well, what shapes have a line of symmetry? So an example, let me go ahead and share my screen here. So if I have, let's say, I'm going to draw like a blocky letter T here. Okay. My T is not perfect, but maybe I'll shave that bit off here. There we go, it's a little better. Okay. Now in this case, does this shape have any lines of symmetry? So the answer is yes. It would have one line of symmetry going vertically like so. Notice this cuts the shape into two congruent parts, but also if you fold it along that line, the T would line on top of itself. So that means that this is a correct line of symmetry. If you had a blocky letter H, okay, it's not perfect, but imagine it was. This one would have two lines of symmetry. One line of symmetry going horizontally. Notice if you fold it along that line, the H would fold on top of itself, but also one line of symmetry going vertically like so. So if you fold it along that line, you would have the H on top of itself again. So some shapes have one line of symmetry, some have two, three. Some shapes have infinite lines of symmetry. In fact, a circle has infinite lines of symmetry. And some shapes don't have any lines of symmetry at all. But that's what this discussion is going to be about. Now, if you look at question 1, hopefully you have your textbook open to page 568. And if you look at question 1, it says, use a straight edge to copy the rhombus at the right. So I just used some tracing paper and I traced that rhombus there. So that's the first shape there. Looks like a diamond or whatever. It's got 4 sides and it's kind of slanted. That's called a rhombus. So what makes it a rhombus is all the sides are all the same length. Okay. So a 4-sided shape where all the sides are the same length, that's called a rhombus. So let me go ahead and you could take a look. Here's the rhombus that I copied from the book here using the document camera. And it says, how many lines of reflection, or in other words, lines of symmetry, does this rhombus have? So that's part A. So we're looking for a line that if you fold it along that line, the rhombus would fold onto itself. Okay, so how should I fold it? Well, if I try to fold it, let's say along this line right here. So actually, maybe you can't see that. I'm going to draw a little bit darker. Okay, can you see that line? Okay, good. Now, if I fold it along that line, would the rhombus line on top of itself? So let me fold. And you can probably see that this rhombus would not line on top of itself perfectly, right? Maybe you could see through the tracing paper. It didn't really line up. I can see what's behind there. See that? Like it didn't really line up perfectly. Okay. But perhaps this has a line of symmetry some other way. And in fact, it does. So where would the line of symmetry be for this rhombus? Well, there's one line of symmetry going diagonally through the diagonal corners like that. Okay, so this would be an example of a line of symmetry. Notice it breaks it into 2 equal or congruent triangles, but also if you fold it along that, the rhombus perfectly folds onto itself. Okay, hopefully you can see that there, that it would fold perfectly on top of itself. Okay, and it actually has a second line of symmetry going through the corners diagonally the other way. So every rhombus, this rhombus included, has two lines of symmetry going through the corners like that. Okay. So what I want you to do is for question 1 on your packet, which on your packet, it's on page 23. For question 1A and 1B, what you're going to do is copy the rhombus from the textbook and make sure to draw those two lines of symmetry in. Okay, that's number 1, parts A and B. So make sure you draw, hopefully yours looks better, but I'm going to draw basically what you'd want. You'd want the rhombus, and you'd draw the two lines of symmetry. Okay, you can see it, copy the rhombus from the book there, the textbook. Okay, now let's move on to question 2. So question 2 says, do all parallelograms have reflectional symmetry? In other words, do all parallelograms have a line of symmetry? So as we discussed, the rhombus did have two lines of symmetry, right? And a rhombus is a type of parallelogram, right? It's a parallelogram with all 4 congruent sides. So it is a parallelogram, and this one does have two lines of symmetry. But do all parallelograms have lines of symmetry? Well, let me take a look. Here's another parallelogram that I drew earlier. Okay. Does this have lines of symmetry? Well, let's check. So let's check if it has the diagonal lines of symmetry like the rhombus did. So I'm going to use my straight edge here, and I'm going to check to see if the drawing along the diagonal, I'm going to check to see if that's going to be a line of symmetry. So I did break it into 2 congruent triangles, but would it fold perfectly onto itself? Let's go fold. You can probably see behind the paper that it didn't perfectly line on top of itself, right? Do you see how this corner here does not line on top of that corner when you fold it? You see that? So it doesn't look like that diagonal is a line of symmetry. That's not a line of symmetry for this shape. Well, what about the diagonal going the other way? Would this be a line of symmetry? Well, let's check. So I'm going to fold my shape along that and see if my shape lands perfectly on top of itself. And once again, you can see it does not. See the corner, this corner you can see here does not fold perfectly onto that other corner, right? So these diagonals are not lines of symmetry for this parallelogram. Now it did work for the rhombus, but it does not work for this parallelogram. So what we want to say here is for this question 2, we would say that no, not all parallelograms have reflectional symmetry. Okay, only special parallelograms do. Like rectangles and rhombi, they have lines of symmetry, but a parallelogram that's not special, like the parallelogram we just demonstrated, does not have reflectional symmetry. So I want you to explain that there. Some parallelograms do, special parallelograms, they do, but normal parallelograms, they do not have any reflectional symmetry. All right, number 3. Number 3, if you look in your textbook, says the isosceles trapezoid at the right has only one pair of parallel sides. How many lines of symmetry does the trapezoid have? So you can see, hopefully you have your textbook open, but you should be able to see a trapezoid like this one here. Okay. Now we want to see, does this shape have any lines of symmetry? Well, yes, it does. Hopefully you could see it right away. It would be a line of symmetry going vertically through the middle. Okay, this would be a perfect line of symmetry because if you fold it along that line, the trapezoid would perfectly line on top of itself. You can see that there, that it perfectly lines on top of itself. Okay, so for number 3, it asks, the isosceles trapezoid at the right has only one pair of parallel sides. How many lines of symmetry does the trapezoid have? So in this case, it would have one line of symmetry. And you can, and I would suggest saying that it has one line of symmetry, but also drawing it out. So draw out the trapezoid. That's what I would suggest. and show where the line of symmetry would go. Okay. And then you would say in a sentence that this isosceles trapezoid has one line of symmetry. Okay. Now question 4 says, do all isosceles trapezoids have reflectional symmetry? So do all shapes that are like this one, do they have reflectional symmetry? Yes. So if it's an isosceles trapezoid, then we know for sure it'll have at least one, it'll have one line of symmetry. So if it's an isosceles trapezoid, it will have one line of symmetry. But then it also asks for number 4, it says, do all trapezoids have reflectional symmetry? So what if it's not isosceles? What if it's just a regular trapezoid, not isosceles? So that would look like this one here. Okay, so here's a trapezoid, but it's not isosceles. So would this trapezoid have any lines of symmetry? Hopefully you could see that it would not. No matter how I tried to fold it, I could not fold this shape onto itself perfectly. So if it's a trapezoid that's not isosceles, then it will have no lines of symmetry. So you want to state that as well. So for the full answer for number 4, it really has 2 questions. So do all isosceles trapezoids have reflectional symmetry? Yes, isosceles trapezoids will have reflectional symmetry, but it has to be isosceles like this. And then the second part says, do all trapezoids have reflectional symmetry? We want to say no. Only isosceles trapezoids will have that line of symmetry. If it's not an isosceles trapezoid, just a regular trapezoid, it will have no lines of symmetry. Okay, so I want you to explain that there. Okay, and that's it for this activity. I hope that made sense. Let me stop presenting here. Hope that made sense. Hope you're able to get everything out of it. And with that, I will see you guys next time. Have a great day.